All right, Lab 5, the code skeleton. Again, these should start to, they're going to start looking pretty regular to you, okay? Again, up at the top, we import some stuff, set up a certain type of, group of pins, right? We're going to say pin 12 is an input. We set it to a pull up, which means it's by default high, and then whenever we push it, it's going to be low if we tie it to low, that is, to ground. We're going to say pins 20 and 21 are outputs. An interesting thing we're going to be doing, we haven't seen this before, is we're actually going to create what's known as a PWM, a pulse width modulation object, which is related to pin 20. And what we're going to say is that pin will, instead of being on or off constantly, like when we say it's on, it stays on, it actually is on a certain fraction of time and off a certain fraction of time. Okay, in particular, it's going to go on and off 440 times a second. And what PWM is, this isn't really necessarily a part of the course, but it's good to think about because a lot of you in First Robotics use PWM all the time. What PWM is, so normally a switch will, if you go on, it just goes from 0 volts to, in our case, it's 3.3 volts. All right, and then and then if we go off, right, like these are our on event or off event, right? What PWM is a way to sort of get a shade of gray in our on amount, okay? Because remember, in a digital setting, right, you are either off or on. There is no in between. But what you can do is actually in PWM, like whenever you say, let's go 50% on. So what it does is it goes on and off, like this, okay? So it's actually going between max and not max. And I'm drawing kind of crappy drawings here, but just to get through it quickly. But what happens is if you were to take the integral and then average, or I mean, do the time average of the on to off amount, right? You get, 50%. All right. And the frequency, the rate at which you go on and off is known as the PWM frequency. In our case, we're going to say it's 440, which is a nice clean concert A. All right. So we're going on and off at 440 times a second. And the percent, so 50%, so that's a term we call duty cycle. And so when the duty cycle is 50%, that means we're on and off 50% of the time. And, a time average amount of voltage is, in our case, it would be about 1.65 volts, okay? If you were to make your duty cycle bigger, it would be, if we were to zoom in a little bit, instead of being on, off, about the same, this would maybe be 50%. So let's say you're doing 90% duty cycle. That's on like this kind of. So you're on 90% of the time and then off 10% right here, okay? So that's 90% duty cycle. And then that means you're on about 90% of the time. Time averaged, you're about 0.9 times 3.3 volts, okay? So it's a way to actually make a sort of shade of gray of onness or offness rather than just being on or off. Another nice thing about it, what we're using it actually in particular in this class, in this lab, I mean, is we're actually making it drive a piezo. So a piezo is those little black round thingies that you have, and they have a hole right here and 2 pins coming down, okay? And if we were to actually crack them open on the inside, you have, some sheets of piezoelectric crystals, right? And what happens is when you apply a voltage across them, those crystals flex, okay? So maybe like it starts up like this, and then whenever you apply a voltage, it goes down, and when you unapply that voltage, it goes back up. So by going up and down like this, you actually generate sound waves, all right? And since we're applying that on-offness 440 times a second, what we can do is make this crystal vibrate 440 times a second and then push air at 440 times a second, which is then the essence of sound, right? So what we're doing with this part of the code is actually giving our system the ability to make a tone through a piezo in addition to regular old pin 21 right here, which we'll just be setting on or off, okay? So another thing we're going to have in here is, let's scroll down a little bit. So another thing, we have this voice function, which we talk about in the lab, so I would read through that and play with that a bit. It's pretty cool. We have 2 lists we're giving you, sound delays and light delays. These are lists which you will build up yourself to record how long it takes you to push a sound, like respond to a sound stimuli or stimulus or a light stimulus. And then our main loops down here, okay? Again, a try except. Finally, you should be getting pretty used to these. Our try is, just an introductory welcome thing that the weird British guy talks to us in. Then we have this loop which runs forever, okay? So we say press the button when ready. And then these are some variables which I thought you might want to use, word and timing. And then down here we use them in, coming up with a list or a statement. You responded to a word stimulus in total seconds, okay? And your job is to figure out what word and, wait, why is total there? Oh, that should be timing. In timing seconds, okay. So your job now, like the code you're going to have to write is to basically implement this. And this is not going to be that different from what you've already done in the last lab, okay? You're going to have to be doing some timeouts. The issue is the timeouts are not fixed, right? You're going to wait until the pushes the button. So, I mean, how could we do this? If we just think of a little bit of a flow, we could come in, like the first thing we could do is, maybe before we even ask the person, so we're going to press the button when ready. So that means we're probably going to, so the first thing we'll probably do is we'll ask them to press the button when ready, and that means we're going to wait until the button gets pushed, right? So we're going to do one of those while, and then a condition, all right, and then we just pass. So we're probably going to be waiting for a while, and this condition right here in our situation will be the button not being pushed, and that's usually, a gpio.input, and I'm writing pseudocode here of whatever our pin is, is some sort of set, right, value. So remember, when a button is not pushed, it's true. When a button is pushed in our class, it's false. All right, so while that's happening, we wait. Then once the button is pushed, we escape from this loop and move on with our life. At this point, this is where you should figure out, okay, through using the random.random function call, am I going to be a lighter sound this time? What is the amount of time I'm going to wait before I present it to the user? All right, so you're going to have to figure out type, all right, which you could just use the variable word to contain. So maybe word could contain light or sound. And then you need to figure out a pause, okay? And we're going to make the pause sort of random because if you know it's going to come after 1 second, you'll be a little bit quicker to respond all the time. You'll like kind of acclimate yourself. So we want to make the pause random too. And what I would recommend doing is make the pause that you're going to wait before you present the stimulus at least 1 second, but less than or equal to 5 seconds, okay? So something like that. Because we don't want to push the button and then immediately have the stimuli come. We want to give some sort of buffer zone, but we don't want to have the person wait like 45 years or something, right? Because then, Raspberry Pi 4 will come out by then. Then after that, we're going to, based on what we're doing, light or sound, we're going to turn on that stimulus, okay? In the case of an LED, it's just turning it on. And in the case of the PWM, there's some code in the lab which tells you how to turn that on, right? You're going to actually change the duty cycle to probably 50% or something. And then after that, you're going to start a timeout. You're going to do start time equals, and then take the time dot time. And we're going to wait, okay? We're going to wait for another condition, right? We're waiting. And what are we waiting for now in this time? We're going to be waiting for the button to be pushed. So while the button is not pushed, pass, okay? And then once that button is pushed, then we're going to say, okay, the difference, right, the new time is going to be based off of our old time minus our starting time, okay? And then we're going to, restart and stuff. So figure out a way to implement this, okay? This was sort of pseudocode, what we just did right here.